In the previous video, we talked about how ions are formed, ionic bonding, ionic compounds, cations bonding with anions to form ionic compounds. In this video, we are going to talk about naming of ionic compounds. First of all, let's talk about naming cations and anions. We name positive ions, cations, simply by naming the element and adding ion at the end. For example, we know that K stands for potassium, so the name for the K plus ion is simply the name of the element, potassium ion. Mg2 plus is magnesium ion because Mg stands for magnesium. Al3 plus is aluminum ion because Al stands for aluminum. Now, we can have metals that forms ions with multiple charges, more than one charge. For those, we must specify the charge on the metal. To do that, we use Roman numerals to denote the number. So if it's a 2 plus ion, it will be the Roman numeral 2. If it's a 3 plus ion, it's the Roman numeral 3, etc., etc. And we put those Roman numerals in parentheses following the name of the element. For example, chromium can form multiple ions, and here we have chromium 2 plus and chromium 3 plus. If we just wrote chromium ion, there is no way to differentiate between the 2 plus ion or the 3 plus ion. The way to do that is by writing the charge in Roman numeral in parentheses following the name of the element. So Cr2 plus is chromium, the name of the element, followed by the charge in Roman numeral, so 2 in parentheses. So that 2 tells me it's the 2 plus ion. The chromium 3 plus, therefore, will have the name of the ion, chromium, and then followed by the Roman numeral 3 in parentheses. So chromium 3 ion. Here is a sample problem that I want you to try. We have calcium, lead, and silver. First thing that we need to do, in this case, to name the following ions is to specify whether these ions form multiple, whether these elements form multiple ions with multiple charges. And we do that by looking at the periodic table. Remember that we talked about how group 1 and group 2 always form the same type of ion. And group 3, aluminum really is the one we're going to talk about, they form the same type of ions. We also talked about how even though the transition metals in general form multiple ions, there are some exceptions. So look back to the previous video and figure out which ones have exceptions and whether one of these will be an exception or not. Then you can figure out whether you need to put the parentheses at the end specifying the charge of the specific ion or not. Here is the list of the most common atomic cations that we're going to use. This is not an extensive list, but it is the list of the most common ones. Note that for those ions that we have form multiple, so those elements that form multiple ions, we have to specify the charge in Roman numerals. So these are all transition elements that form multiple ions, and a few over here. I suggest that you print this list and that you have it kind of handy so that you can refer to it when you're doing problems. How to name anions. When we are naming anions, we write the name of the element, we drop the ending, and we add IDE at the end. For example, we look at chlorine. Chlorine forms an anion, a negative ion, and when we write the name, instead of writing chlorine ion, we drop the in ending and we add the IDE at the end, and this becomes chloride ion. For nitrogen, we say nitride ion, the IDE ending. So anything that has IDE ending, we find the root that tells us the name of the element. So nitr, that is part of nitrogen. So that would be N. And we know that is group 5, so it will form a 3- ion. So nitride ion. And oxygen forms oxide ion. We drop the gen and we add the IDE. Nonmetals always form negative ions of one particular charge. They do not form multiple charges. And so we always know what the nonmetal's charge is going to be, what type of ion they're going to make. Group 7 will always form a -1 ion. Group 6, where oxygen is found, will always form a 2- ion. Group 5, where nitrogen is found, will always form a 3- ion. And therefore, we don't have to specify the charge of the anion in Roman numeral. We never do. Here is a list of common anions. Note once again that this isn't every anion that is formed, but these are the most common ones that we are going to deal with. Once again, I suggest you print them out and you have it handy to use when we are doing problems. Now that we know how to name the metals and the nonmetals, so cations and anions, let's put them together to figure out how to name ionic compounds. Note that we have two types of ionic compounds. We have what is called type 1 and type 2, binary meaning 2, ionic compounds. For type 1 ionic compounds, we name the metal by just using the name of the element. These types of cations are single type of ions. So these are elements or they're metals that only form one type of ions. Group 1, for example, group 2, those metals that are found in those groups always form the same type of ion, so we do not have to use the Roman numeral in that case, and those are the type 1 ionic compounds. Let's take a look. We name the metal first. In this case, Li is lithium. Note that lithium is in a group that always forms, it's group 1, so they always form +1 ion. They do not form any other type, and so we don't have to specify a 1 in Roman numeral. So we write the name of the metal, which is lithium. Then we move on to the anion, which is sulfur. We drop the ending and we add IDE, which becomes sulfide. So lithium sulfide. When we move to the next compound, we have Ba, which stands for barium. It's group number 2. Always forms a +2 ion, never forms anything else. And so we don't have to put a 2 in parentheses here because we don't have to specify it. We always know that it's barium. So barium. Then we move to the anion, which is Cl chlorine. We drop the in ending, we add the IDE, and it becomes chloride. So barium chloride. And lastly, Al2O3, aluminum. So we write aluminum, always forms a +3 ion, do not have to specify the charge. Then oxygen, drop the gen ending and add IDE to become aluminum oxide. When we name type 2 ionic compounds, on the other hand, we have to specify the charge because the metals are transition metals and they can form multiple ions. with multiple charges. They can form a plus 2. Copper, for example, can form a +1 or a +2. So if I just write, for example here, if I just write copper nitride, well, I don't know if I'm talking about copper 1 nitride or copper 2 nitride. They are two different compounds with two different ratios, with two different formulas, and they have different physical and chemical characteristics. So I have to specify which copper nitride I'm talking about. For these types of, so type 2 ionic compounds, in addition to naming the element's name, the metal's name, I have to put the Roman numeral with the charge following the name of the metal. For example, cobalt, in this case, is cobalt 2 because I have two chloride ions. Each of the chlorides is a -1 charge. That means that I have a total of -2. Because I have a total of -2 charge, and this is a neutral compound, that means that my total positive charge has to be +2 to counteract the total negative charge. And I only have one cobalt to take on that negative charge. So cobalt in this case is a +2 ion. We then write the name of the ion, cobalt, followed by the Roman numeral 2 in parentheses, and then I write the name of the anion, which is chloride with an IDE ending. I don't have to specify the charge because chlorine always forms a -1 ion, the chloride ion. Let's take a look at the chromium oxide. Let's figure out what the charge is going to be on the chromium. I have 3 oxygens or oxide ions. Each of them I know has a 2- charge because remember from the previous slides that all of the nonmetals, all the anions are always the same. So oxygen being group 6 will always form a 2- charge no matter what. And because I have 3 oxides, 3 of those ions, each of them has a 2- charge, I have a total negative charge of -6. 3 times 2- gives me a 6-. All of that negative charge has to be offset by my metal, my cations, because the compound has to be neutral. So my total positive charge has to be +6. Now I have 2 ions to share that total positive charge of +6. So I take the total positive charge and I divide it between 2 ions, and each of those will have a +3. So a +6 total divided between 2 ions gives me a +3 for each chromium. And that's how I know that I have a 3, chromium 3. So when I write the name of this compound, I will write the name of the metal, which is chromium. I will specify the charge in Roman numeral 3. Close parentheses, and then that will be followed by the anion oxide with the IDE ending. Let's figure out how to name or how to specify the charge on the copper. Nitrogen forms a 3- ion. So the nitride ion is a 3-. I have 2 of those ions. That tells me I have a total negative charge of -6. 2 times 3- gives me a negative charge of -6. That has to be offset by the coppers because the copper is my cation. The total positive charge has to be +6 for it to give me an overall 0 charge. Since my metals have to have a total positive charge of +6, but I have 3 of them. So I take the total charge, that is a +6, divided between 3 atoms. It gives me a charge of +2 on each ion. And so my copper is a +2. When I write the name of this compound, then I write the name of the element, which is copper. It is a +2 ion, so I specify the charge in Roman numeral 2. And then I write the name of the anion, truncated with the IDE ending, and it becomes nitride. So copper 2 nitride. Here's the flow chart. If the compound contains a metal, and the metal will be listed first. So if your first element in a binary compound is a metal, most likely you will have an ionic compound. There are two types of ionic compounds. If my metal cation can only form one charge, so if it's a group 1 alkali metal cation or a group 2 alkaline earth metal cations, or these exceptions from the transition elements, then I just write the name of the metal followed by the nonmetal ending in IDE. If my metal cation can form more than one possible charge, typically the other transition metals, then we name the metal, specify the charge by a Roman numeral in parentheses, then write the name of the anion just like we do here for type 1 by adding IDE to the root of the element name. Here's an example that I want you to try. Determine the name of each of these compounds. First, you have to look at the metal, which is listed first, and you have to determine, is this a type 1 or a type 2 compound? And if it is a type 2, figure out the charge on the metal by computing the total negative charge, making that equal to the total positive charge and distributing that total positive charge amongst however many ions that you have, 2 or 1 or whatever the case might be. I will give you some time to try these out.